Terraforming Mars. This is About Space Today's special report. I'm David Denault. Today, we're going to examine the possibility of terraforming Mars. And let me begin by sharing a report from a retired NASA scientist. Well, Jim Green, who served as the chief NASA scientist for 40 years, just retired. Well, Jim Green says the solar system is ours.
The solar system is ours. Let's take it. And that, of course, includes Mars. And for humans to be able to explore Mars together with us doing science, we need a better environment. Early on in its history, Mars had a significant amount of water, but it went through rapid climate change, and now it's a very arid planet. The solar wind, after Mars perhaps lost its magnetic field early on in its history, has been pounding Mars. We now know that Mars has lost between 80 and 90% of its atmosphere. How can we change this? How can we improve this environment? Well, if we let nature take its course, this might be more than 700 million years into the future. So are there things that we can do that can help mitigate some of these extremes on Mars and provide a better environment for science and exploration to coexist on the surface? To look at the tools that we currently have to be able to understand the physics of what's going on.
Joining me once again is planetary scientist Dr. Ryan Ogliore of the University of Central Florida. Welcome back, and thanks for taking time to discuss the idea and the possibilities of transforming Mars. Ryan, is terraforming based on water and having it evaporate into the Mars atmosphere?
Yeah, that would be one way to do it. So the basic idea is that we want a place like Mars to be just like here on Earth, and it's not. And so we got to change it on a global scale to make it like Earth, where we can walk outside without a spacesuit, that there could be liquid water on the surface. And so it basically has, for Mars, it basically has two components to it. One is that you got to increase the pressure and the temperature of the atmosphere so that liquid water can exist on the surface. And the second is you need to have some process like photosynthesis to create that oxygen that you need in the atmosphere to make it breathable and to make it comfortable for humans to live. So there are two different ways to do that. People usually divide it into the first and the second, and because the first has to come before the second, and the first, there's a little more tractable solutions. So you got to put something in the atmosphere that really will increase the greenhouse effect. So what you want to do is keep that heat in and let the sunlight in and not let the heat out, not let that thermal energy out, but let that sunlight in.
My next question is, do we have an umbrella big enough for those gigantic rays coming from the sun to protect the Mars planet?
Yeah. Well, effectively, we have these chemical umbrellas, right? And we see that in many different contexts, like here on Earth, we have carbon dioxide as a greenhouse gas. On Mars, some very smart people, like the people I work with here at UCF, have thought of some really cool ideas. And my colleague Ramses Ramirez here is working on an idea to release aerosols, so very small particles in the Martian atmosphere. He has an idea to make them from aluminum and iron, or maybe even carbon, like graphite, that you'd get from either converting CO2 to oxygen to make breathable oxygen or rocket fuel on the surface of Mars, or just from minerals in the on the Martian surface. So you can make little metallic rods that have some length to them and eject those into the atmosphere. And what those do is those cause the incoming incident light from the sun, which is not that much dimmer. It's a bit dimmer than it is here on Earth, but it's still decent. And that incoming sunlight will then scatter down to the surface, and those particles will kind of trap like a warm blanket, keep that infrared radiation onto the planet's surface. So what they found was that those doing it that way, those particles are thousands of times more efficient than using the traditional greenhouse gases that we're used to here on Earth. and you can warm the Martian surface pretty efficiently using those kind of nano-engineered nanoparticles. It's pretty neat stuff.
Is this achievable in our lifetime, or is it going to take thousands of years to terraform Mars?
I think the end result of having a habitable Mars is not in our lifetime. Getting ideas, and this is the tough part about the space business, is that, you know, the goal of all of this is to extend the reach of our species, just in case an asteroid comes and ends the habitability on our own planet. We need some a way, we need to be a multiplanetary species, and this is a step a step there. And we want to, have some Earth-like planet around some other star, but we're not there. You got to take one step at a time. So I like, I like these thinking about these things in an engineering way, step by step. So that first step of trying, engineering these particles like the ones I talked about and trying them in the lab here on Earth and getting the infrastructure to do this on Mars, if that's something we want to do. And there's a lot of ethical questions and political questions related to spending the money and having that kind of cosmic impact on our neighbor planet. That's something we can do now, and that's something we can invest in. And it's a materials question. It's a very science engineering question. We can think about these things now, but looking up and seeing that red planet as blue or green, that's not going to happen in our life. I can almost guarantee that. There's a lot of uncertainty, but that's not going to happen when we're alive, unfortunately.
Is there something else you want to add to the terraforming debate?
Ramses Ramirez and his colleagues are thinking about how to use materials on the Martian surface, because that's the only way that you can get these global scale changes, is if you do it in situ. And I think in general, this is how we're going to make Mars safe for human astronauts, is if we can develop the in situ use of resources that are already there, because we can't bring that stuff to Mars. It's too hard. Certainly with current technology. So if we can exploit some of the minerals and the resources that are already there to do what we want to do, that's the way to do it. And the good thing about that is that we can practice here on Earth and figure these things out on Earth with a relatively low cost before we make that big step to Mars. And I think that's part of the economies, is like, you start with a little bit of money, a little bit of investment, and you make these incremental steps. And that's how we got to the moon. And that's how we do all these amazing things, is that we need these small steps. And so, colonizing some exoplanet is infinitely expensive and infinitely challenging, but thinking about the smaller things, that's where I like to do stuff, and that's where I get excited, and where we can actually make real change, and we'll get there eventually, but you have to be excited about the small stuff too that leads to the big stuff.
Join Dr. Ryan Ogliore and me next Wednesday as we explore the moon Titan, not Mars. And continue to check out our Facebook page at aboutspace.today for special reports, launches, and landings. And if you like our report, click like, follow, and be sure to hit that subscribe button. And to all our listeners around the globe and here in the U.S., thanks for taking time from your home or from where you work to listen today. I'm David Denault.